Hi everyone, it's Sorkan. Today we have a problem when we are given a root of a binary tree and we need to return in order traversal of its nodes values. So let's take actually one binary tree here. So let's say that we have here 2, we have here 1, and we have here 3. Okay, so what is the in-order traversal? In-order traversal is when we are first visiting the left node, right? Left node, then we are visiting root, and at the end we are visiting a right node. So in this case, for example, we are first visiting the left node 1, right? Then we are visiting root 2, and we are visiting right node 3. Okay, so how about in this case? In this case, so in the example 1, we are visiting first left, right? We don't have left, then we are visiting root. So we are adding 1 here, right? 1. Then the next one, what is the next one? We are visiting 2, but the 2 has its left, right? So we need to first visit the left of the 2 here. So we need to first visit 3. So we are visiting 3, right? And then we are visiting root, we are visiting 2, and there is no right, so this is our result, which we are returning here. Okay, since we are going to return the list of integers as a result, let's first create our result integer that we are going to return. Let's just call it a list result, and it's a new array list. Okay, that we are going to add and return our result. Okay, and we are returning our result. And next one is let's check first that if our root is not equal to null, right? If our root is not equal to null, then in that case we are going to call our function that we are going to create in a second recursively. Let's call it traverse, and we are going to call our function. We are passing here our root, right? If our root is null, then we are just returning empty result. So we are passing our root, and also we are passing our result. Okay, so let's create our function now, and our function is it's going to be void. It doesn't return anything. So traverse, right? And we are passing here what? We are passing here our tree node, right? We are passing here our tree node. Let's just call it a node, right? And we are passing here our result, right? List of integers, right? List of integer, our result. So what we are going to do here, so by requirement, the first thing that we are doing, we are visiting the left node, right? We are visiting a left node. Let's check that if our node left, if that not equals to null, right? If that not equals to null, then we are visiting our left node. So we are recursively calling our function traverse, right? Traverse. We are calling our function, and we are passing here our node left, and we are passing here our result, right? So what's the next one? Let's say that we have visited, and we visited the left, the node that is on the left, right? So we don't have any more nodes. So this is our mode. This is our leftmost node. So then we need to add the result to our, then we need to add the value to our result, right? So that's what we are exactly doing here. We are adding to our result node, right? Node value. And the next one is we are calling we are exactly doing the same. Actually, we can copy paste that here. We are doing exactly the same with our right node, right? Right and right. So why we are calling this function, why we are adding a result not before it or after our node, because for example in our first example, right, that we have seen, before adding the value of our right, we need to add the value. If let's say that our right has also a node on the left, we have to visit that node first. So again, like first it comes the left, root, and the node. Let's say that we have visited left and we added value, and now we want to visit right. But before visiting right, if there is any value, if there is any node on the left of that node, as an example 1, right, we are adding that result to our result first, and then we are adding the value of our right. Okay, what's the time and space complexity of this solution? The time and space complexity of this solution is since we are visiting all the nodes, it's n, right? And O of n, and for the space complexity, it's determined by the size of our recursive stack. So in the worst case, it's gonna be also O of n. Let's run our code. Okay, great. It works as expected. That's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.